Hello, Raiders. What an unfamiliar bunch. Thank you for the follow. Let's get some music going. Let's see here. Ooh, some Coheed and Cranberry to start the morning. Can rock with this. All right, let's get set up here. Our font is way too large, so let's bump this down to 26. And we'll go there, and we will get out of NeoVim. And let's go to our sessions. Why can't I get to my sessions? There we go. We are gonna go to Dune RPC. Oh, god damn it, bad cop. Freaking bad cop. Ugh. This is bad cop's fault. Somebody clip that. Okay, so what we're working on this morning, y'all, is a OCaml library called Serde, which is a port of Rust's Serde to OCaml. It was written by Leo Stera, and specifically, I am working on writing a serializer and deserializer for S-expressions. S-expressions, if you're not familiar, look like this language here. It's basically just a bunch of parentheses, and you can have values and lists, right? So anything inside parens is a list, and then this is a value, and then we have another list, and then we have a value, so on and so forth. This is just it's like JSON, just kind of lispy. It's used as a serialization format for a couple different libraries or services or tools in the OCaml ecosystem. So yeah, we are working on that. But I am going to go run to the bathroom real quick and make sure that my coffee's ready to go here in a little bit. So I will be right back in like 2 minutes. Hang tight. It's so funny. Okay, so yesterday we ended by working on deserializing options and figuring out our strategy for that. And we also wrote a whole parser for our S expressions. So we look and go look at what our parser looks like, or I guess it's kind of a lecture parser in one. But we use this library called setx to essentially parse tokens and characters and different bits out of our S expressions. Oh man, DevDad got me getting up early. Thank you for the follow there, Stubborn. And Fabi Serde is a OCaml library that is a port of Rust's Serde. So if you want to take a look at what the GitHub actually looks like, here is a link. And we'll just keep this, let's bump that over to the side, and we'll bump this over to the side. Great. All right. So we want to drop into here, and we need to continue working on our deserializer. Right, so we got through this yesterday, and the next bit up is deserializing an identifier. So this means that we want to take an S-expression to some OCaml type. So let's see how Leo did this in here. Oh, we have a visitor. Visitor.visit string. So I think we might potentially be able to use the exact same code. So let's just uncomment that. I think this probably works, right? So we just come up here, we call parser.readString. That goes to our actual parser. We skip white space, and then we say, hey, if we hit a thing that starts with a open paren, we're going to take all the characters until we hit a another paren. So that looks good. Thank you for the follow, Celsco Costa. Super appreciate you. Why did that not work? I don't want to listen to you. Oh, yeah, let's listen to set your goals. All right, so we do that. The next one is serializing a list. So let's uncomment that. So I think we don't have a open bracket, but we have a start list. So I think we can say this will be read left paren, and this one will be read right paren, because that's how S-expressions do lists or sequences. So that should be okay. I actually don't know how this works. Okay. So now, this one might be a little trickier. So I think we're gonna want to peek on this, and this will be a right paren instead. So how does his parser for read comma work? So this is gonna lex vlex box. I assume this probably just reads until we hit a comma, or reads till the next comma. I think we're gonna want to read white space, because the way JSON would work, right, while I have a bunch of buffers open. Oh, we can, oh, this buffer, I should just quit out of all this so we get a fresh state. Yeah, let's save this over here. Where's our other error here? That's okay. So let's write, and then we'll write quit out. Great, we can quit out of that, and then back in here. Great. So when we deserialize an element, we should look at how we serialize an element, right? That will tell us exactly how to parse serialized record, serialize record variant, blah, blah, blah. Else, white space. Yeah. So our parser is probably going to need, our parser is probably going to need a white space reader, which I think I have. I have a skip white space. But do I have a read? So we probably want a change. This will be read white space. And this will be not star, but it will be we're going to do that, and then we'll say anything else. We're going to get an unexpected Lex error. This will be yanks around that with that, and we can say as Lexer, as Lexer. And then this will be changing word, white space. How to install Ghosty? You have to join the Ghosty Discord and get into beta. Just by joining the Discord, you become eligible for the beta. And he invites in waves. So here's the link to the Ghosty Discord. Hi, what's up with the project? Yeah, we are porting, we are helping someone else in the OCaml community, specifically Leo Stera, port serde from Rust to OCaml. It's not a direct one-to-one mapping, but relatively close, and we are working on writing a deserializer, parser lexer, and for S-expressions rather than JSON. So we now can read white space. So that looks good. If we come back over here, we should do, so we're saying if it's the first element of a sequence, we want to say okay, otherwise we want to read white space. Read white space. And we set our state to rest. I think that looks good. I think that's what we want. What up, Noons? We should probably actually even commit and pull in any changes Leo made yesterday. Git commit a m, and we'll say whip on S-Expression deserializer. Give that the old push, and then we'll do a git fetch upstream main. And we'll do a git rebase. Oh no. Oh no. What is this? Oh, come on. I feel like that's pretty clear. I said his handle, Leo Stera. Whatever. Menace. Upstream main. And let's see here. We can basically just squash everything, right? Squash, 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 squash. Squash says mail it into the previous commit. This will be the first one. That should be good. There we go. And we'll do pushed force with lease. Great. So we should have any new things that, let's go ahead and look at the, jump down here and get Dune running in build mode. Oh, I am so freaking tired. I might have to go make another cup of coffee earlier. All right. Sorry, I'm just checking notifications on my phone. Okay. So let's go look at the JSON deserializer again. Don't need that, don't need that, don't need that. Okay, so we can probably read colon. So we probably need to look at how we are, oh shit, we got another raid from Sabine. Hello, Sabine. Hello, raiders. How are we doing? How's your stream? What were you working on? Ugh. OCaml.org issues and pull requests. Nice. Anything good or of note? Nice. Hell yeah. All right, so we are probably going to need something different for our new type. Good morning, Trash Puppy. And yes, thank God it's Friday. Yeah, Rio is from uh, Riot's ecosystem. Let's see here. That's actually what we're doing right now. Fab is working on stuff to support the Riot ecosystem. Thank you, Ryan. I agree, Sabine. So when we serialize a new type variant, we serialize it to this. So if we did this in JSON, it would be, yeah, he's looking for the colon, right? Or no, wait, how does this work, actually? Here we go. This is what we were looking for. So there's the JSON new type, and our new type is going to be up here for serializing, right here. So I think this is saying, what I think this is saying is we're going to expect that the next character is a colon. How would that work? We'd have a key. So hold on, let's type this out. Let's do a similar example, right? So let's copy this and let's imagine what this is doing in JSON rather than S-expressions. So let's dump this here and an event, and this is going to serialize to what I would assume to be something like this, right? I would assume it would do this. I actually don't know for certain, though. So we're beginning an object, right? Yep. So we begin an object. We begin object key, which is probably a quote. We write the constructor name, which is int. We end the object key, which probably gives us another quote. And probably a colon. Begin object value is the colon. Okay. Then we get our colon. And then we serialize the value, and then we end the object value, which is just going to be sure. Do we call end object? Yeah, there's end object. Okay, so that makes sense. But when we deserialize a new type, I don't actually understand how this works. Because it reads a colon. So do we already get, it must be like some outer parent object, right? Because we would probably have something like, I don't know, my object. And then we'd be in here, and then we'd have like I'm guessing it choose that and then deserializes this. So I think, what do I think? I don't know what I think. I don't get how this works. Do you do streams where you teach OCaml lessons? I do not, but I am more than happy to help with OCaml questions. Thank you for the follow, CalVegas7. Appreciate you hanging out with us. Ah, okay. So deserialized variant must end up calling. Okay. I see. So that's where we drop into unit variant, new type variant. So let's say we hit a variant, right? We skip space, we peek, we see it's the start of an object. We skip space, we visit variant, which I don't know what this necessarily gives us. Some A. I don't know what case this handles. Maybe that's just maybe that's the case where it's a unit variant. So I guess we can assume in our new type variant that we've already hit the outer thing. So we've read an object start. We chew that white space there. Yeah. We hit a string, right? We skip space. We visit the variant. That must give us the whole object. And in a tuple variant, okay. Okay. I think we might need to yeah, Vim or I almost called him Vim Dad. Dev Dad is officially Vim Dad. So let's just uncomment a bunch more of this down to deserialized variant. So I think we want to start here. Vim Daddy is way different than Vim Dad. Prime is definitely Vim Daddy. Dev Dad is Vim Dad, and Teach is Uncle Vim. I think that works. Meta is more like your creepy uncle, you know? Only creepy uncles use Emacs. Yeah, just walk past him. Don't make eye contact. Don't interact with him when he's talking to you. Just keep going and mind your business. So when we hit a variant, I need to go look at our serialized variant again. I should just split over here, huh? Do we not have a serialized variant? I guess we don't either. Okay. Okay. There's an extra one there. It's not that sus. Listen, I'll accept Ved or Zed. I don't know why I said Ved. Good lord. So I think we have to do something like we did. I don't think we need to do white space. Well, we'll say something like if I mean, we could also peek, right? Yeah, we can. We can just call deserialize element, right? Because that's we get the nice benefit that everything is like lists and atoms. Is that what we're calling here? James Dev, I thought OCaml was relatively new compared to Rust or Go because of how much I've started seeing it pop up lately. Boy, was I wrong. Yeah, it was made in the early 90s or something. And the reason you're seeing it pop up more is because it got a really, really big release last year. OCaml 5 came out, which gave us multi-core. And yeah, it's basically like garbage collected Rust. So if we do a tuple variant, how do we serialize a tuple variant? I think we can just keep doing. I think all of these are deserialized element, right? Unless this isn't correct. I'm a little bit confused why we have to read a colon here. Like, what is this actually doing? What up, Priv? Yo, good luck, Badger. I hope you get it. Okay. So in JSON, what does a tuple variant deserialize to? Or serialize to, excuse me. So we go look at serialize tuple variant. We're saying that we begin an object key, we write the key, we end the key, we start an object, we serialize a sequence. So if we serialize a sequence, if it's the first one, we begin an array. Otherwise, we serialize self and elements, and then the end of the array. So then I'm assuming for each element in there, if it's the first, we just return okay. Otherwise, we chew through or we print a comma. We have this state to say we're printing the rest, we're serializing the rest, and then we serialize elements, which just probably goes to like a serialized value, probably. Or serialized field. If it's the first. Okay. This is mind-bending. This would probably become sequence. I don't know if we need that. Because when we serialize a variant, I think we might have to do, if anything, we would have to do parser dot, we would probably like want like a read L paren. What do you return? What star? We probably have to do like that. So we hit that, and then no. I think we can disregard that. I think we can disregard that. So this will be change around that to a left paren. And we would say, I guess we read object start. This would be read L paren. We wouldn't do that. We grab our value, and then do we really need to skip space? No. This becomes read R paren. And this will be something like this. The good thing is once we get through these next couple ones, we can write tests, or we can use the exact test suite and validate a bunch of this. So let's get through this, and then I'm going to make another coffee because I'm freaking tired. I honestly think tuple variant can just be this. And I think that's the same thing. What does a record variant in the JSON one go to? Begin object, serialize the value, and the object. Hold on, chat. Let me go take care of the dogs. Miss Winnie. What are you doing? Stop it. No barks. Hey. No barks. No barks. Bad. Relax. Relax and be nice. You can come in. Thank you for the follow, Caddy Shot. Yes, you're a good boy, Bodie. You just can't bark. You don't bark. Okay? We don't bark. I know. You're probably hungry. Justine will be home soon. So I'm so confused how this works. So right, when we're looking at Leo's serialized record variant, I technically have 3 dogs. Baxter counts as like a half. I have 2 golden retrievers and then a tiny creature that looks like it caught COVID. So when we serialize a record variant, we begin an object. We begin an object key. We write the key. We end the key. We print a colon, and then we serialize a record, which kind of does something similar. Begin object, serialize a value, end object, which this probably falls through to serialize value. Begin object key. Yeah. And then when we deserialize it, that's the confusing part. It doesn't seem to map. So when we... I don't know where this freaking colon comes from. I don't know... Deserialize record. We skip a space. So we read a colon, we skip a space, and then we peek. And I would assume colon space. I just don't understand why we have to. Why he reads this colon. I don't understand how this works or what this thing does right here. Wait, we just went over this.
Bork. I should ban Nightshade, right?
I mean, you are a mod, and Nightshade's not, so you've got the power over Nightshade.
Hi, Bodhi. You didn't feed them, right?
No.
Nightshade's not even a VIP.
Oh wait, I do owe Ryan Winchester this. So when we visit a variant, I assume this just like reads. Nightshade's getting a taste of his own medicine. All right, so I have to write this out because I am like really struggling to imagine what this is actually doing. So let's say we have this JSON object, right? And it's gonna say, we're gonna skip a space and we're gonna peek the reader and we're gonna see an opening brace. And if we do that, we're gonna read an object start, which read object start says read a left curly. Right, so we read that and then we skip a space, so we have a space. And then we visit a variant, and let's say we're doing a record variant. I assume when we hit the visit variant, it determines which of these to go to. And it reads, like, where does the... Maybe it calls deserialized variant again, and we hit this. But then we wouldn't hit a left paren. Where do we deserialize the key? I don't. Does anyone understand how this works? Help. I need help. Oh, help has arrived. Can you walk me through how this... What did I miss? We are working on writing the deserializers for our variants and trying to figure out how this works. And I was trying to step through what was happening here, or guess what was happening here. And I'm very confused. Like, I'm just very confused. So this would be the start of JSON. We skip space, so we then hit here, we parse our object start. That gets that. We skip a white space, so we have a white space here. We go into a value. We visit variant. Do we recall deserialize variant and visit variant? All right, hold on. Let me write this out. So let's say type hello, type hello equals hello of string. And that deserializes to hello value. So when we deserialize a variant, that's going to chew through the space here. And then we're going to hit the quote. We're going to visit a variant. And then when we visit a variant, I don't really know what happens. I assume like under the covers, this is going to call like deserialize self or something. So what is this going to return then? It parses the bracket and then calls the continuation. Okay, so hold on here. Let's comment out these. And it might deserialize it. The continuation here is the visitor. Okay, so if we want to deserialize our variant, which our variants get serialized as just like, yeah. Let's say we did in event, right? It's the same thing. It's this list with two atoms. And then in ours, so we hit this left bracket. Kyle, why are you calling me? I mean, does this look right to you then for my deserializer? So the way I serialize a variant is, so for a new type, we do this. For a record, we do this. And then for a tuple variant, we do this. And a unit variant just goes to this. So it's just a bunch of nested atoms and lists, obviously. That branch doesn't matter to me. Okay. Right. Right. Okay. Okay. There's our continuation. That sounds good. Now let's start with the simple case of a unit variant. Like the deserializer has to follow 100% exactly what the serializer read. Right. So given a new type variant, right? Let me go to my /serialize new type, right? So I serialize to this right here. I can just deserialize a sequence, right? Because my serialized sequence is effectively the same thing. Right? Right, okay. So I really don't want to do this here because I can take care of everything else, right? So you want to see at any single time 3 things. Yeah. The serializer, the deserializer, the data. So if my deserialized sequence, right? So when we hit a variant, we're going to peek to see if we're at an opening paren. And then if we are, we can visit that because all of our variant types are going to start with a left paren and are effectively going to be a sequence. And when we call a deserialized sequence, we're going to go ahead and parse a left paren, deserialize self, and do a right paren. That seems I'm missing a call here. At which spot? Calls the visitor. Okay. The visitor chooses what to do. Okay. So the visitor calls univariant, then goes into univariant. Okay.
Do you need a coffee?
Yes, please. Open the tests. I see. I see. Okay. So I'm starting to see. So here we do need to, our example of this test would be something like, so we would here need to do this, right? And this would be right paren. We call our visitor. We really want to give it, that would just be the A. So that there, but what about for a new type? Do you have a test for a new type? Int I. All variants are the same. Really? Okay, whatever. All right, yeah, let's just save this. And we'll call this, okay, sure. Where did I even save this to? Let's just go ahead and put that in here. Oh God, how did I do this? What a disaster. Why are you not happy? Right, because I have to add it to my modules for it to get picked up. I should move this to JSON. Okay. Leo, can I invite you to co-stream? You don't have to put on a camera or anything. Thanks, Justine. Perfect. Where the hell is my stream together?
Where the hell?
Invite guests. All right, invite should be out. Let me go ahead and change my. Okay. Let me push it through there.
All good.
I have to pause my music. Okay. You should be through there. Great.
Can you hear me?
I can hear you. Can you hear me?
I can hear you loud and clear.
Perfect. Which chat?
You know, I wanted to say, as I've been meaning to say this for a long time, but I love the decoration on top of the couch, like how you managed to get that thing in place. I really like it.
I think it came out really, really well. Thank you. Appreciate that. Let's see here. Audio is good on stream too. Great. Perfect. Okay. So, I actually did the decorations. The concept was Justine, but I actually did it myself. I'll have you know.
Nice. Cool. Okay, so do you want to share your screen over here or?
Oh yeah. Sorry. I'll share my screen. Okay.
I almost feel like on Twitch that should be like the default.
Right.
You know what I mean? Yeah. So we have a rank type here, and it's sort of deriving serialize and deserialize. But the reason I'm asking you to copy this output that comes from letting Dune like print out the derived code is that if we look at a more complex example than the tiny ones we're using for tests, right? I think this will click better. Because when we look at a simple example, it almost feels like, okay, all of the work for deserializing a univariant should just happen when I call univariant, right? But when we look at a complex one, then it makes more sense that it shouldn't. So let's go to the deserialize rank function here.
Okay.
And you'll see that this is quite like a deserializer. It's actually pretty long, I think. But it begins with just the definition of the function in line 7, right? Sorry, I guess in line 60. And then we have this thing called a field visitor, right? That we're going to use at some point in the future to figure out what field are we deserializing, right? What's the name of the constructor, right? Based on a string. You can also define the visitor to map numbers to a constructor, but right now we don't really care because this one was for JSON, right? But if you go a little below line, I guess 72 or something, it says variant, context, rank, and then a list, right?
Yep.
Yeah. And this is where we begin the deserialization, right? So this whole value here, let deserialize rank, that is the deserializer, but it doesn't run yet. Will run later. But when it starts running, it will say, okay, I want to deserialize a variant, right? And that
Okay.
variant has type name rank, and these are all the constructors we have, right?
Okay.
If you find a variant, then you will call the immediate next function, the continuation. So we go into that fun that is right below, right?
Yep.
And if you found a variant, the first thing we're going to do is try to get the tag, the constructor, right? And we do that by calling identifier, which is like deserialize an identifier.
Okay.
And as I read this, I realize maybe it'll be more readable if all of the deserializer functions actually start with deserialize. So you say deserialize variant, deserialize identifier, and so on. But anyway, so in line 72, right, we need to eat away the first characters of whatever serialization we use for a variant, any variant, right?
Yep.
That's why in the JSON one, we check for a brace, right, or a
Yep.
comma, right,
So we need to eat
in the
these.
JSON deserializer. That the thing you're selected or on right now is just metadata for the format. It's essentially pointless right now. Like we can ignore that.
Oh, okay. Sorry.
No worries. And then when we call identifier, we will try to parse, like read more from the raw data, right? An
Yep.
entire tag, an entire identifier. So can you open your format deserializer side by side?
You want me to do JSON or S-Expression?
S-Expression is good.
Okay.
So on the left, when we call variant in line 72, we're calling deserialized variant on the right,
Okay.
right? So that's the
Yep.
first thing that happens. And we read the left parentheses, right? And then we call visit variant, right?
Yep.
And when we call visit variant, then we go back to the left and we run that function that is right below there, right?
Yep.
No, the visitory
No.
is going to be called in just a moment. But
Okay.
remember that we are working here with continuations. So if you say variant and you give it a function, right? That function is the next thing that will happen. So
Oh, right,
could you
right.
enable absolute lines just for while we're doing this?
Mm-hmm.
I would really appreciate that.
I need to make a toggle to turn that off. What is it? I don't even know how to set this. Lua.
Set
Vim
no
dot-
relative.
What is it?
Set no relative.
Set no relative.
Set and then no relative.
There we go. There we go.
There you go. Oh, thank you so much. It's crazy. It's such a small thing, right? It just makes me very nervous. On the right side will be great as well. So then I can match up the line numbers essentially. Perfect. Okay, so we have line 72 on the left, right? Goes to line 359 on the right. And then line 363 on the right, goes down to line essentially 73 on the left, right? That
Okay.
function. And he calls that function. And now
Okay.
that function executes, so we go line 74, right?
Yep.
And then on the right, let's search for deserialized identifier.
So right here.
Exactly, calls that one, right?
Yep.
And then this gets the string from the parser and then calls visit string. So line 328 on the right calls line 63 on the left.
Okay.
And then we go from that string into this little polymorphic variant, right? So now we go to line 75 in this same file. And we do the match. And then you know which constructor you're on, right?
Yep.
And if you can sort of move this a little up, because we have a lot of constructors here. There you go. The ensign constructor at the bottom corresponds to a unit variant, right? So
Okay.
if the tag, and this is just regular OCaml code, right? Match on the tag, follow, then that means line 103 will call unit variant, and that will go to deserialize unit variant, right?
Yep.
But at that point in time, you already have eaten the open parentheses, and you already have eaten the string that corresponds to the ensign constructor, right? So the
I
only thing
see.
you have left to do is like the actual body of the univariant, and univariants are usually empty. So I think if you open the JSON deserializer, the deserialized univariant should be like okay. Like
Yeah,
I don't
yeah,
think
yeah.
it does much.
I copied that verbatim from you in my,
Cool.
yeah, right here. It just
Yeah,
returns
like it
okay.
doesn't have anything to do, so it doesn't do anything. Some formats maybe have something to do here. I don't know. So if we go back to the left, assuming we had another one, like for example, let's grab the record variant, right? Then in line 76, we match on Captain. Then line 77 runs record variant, and that runs deserialized record on the right.
Okay. I don't have that implemented yet, but
No worries. But essentially, deserialized record expects the immediate first thing to parse to be the record, right? Like it doesn't know anything about the wrapper for the variant itself.
yeah.
So essentially, every one of these tiny little functions we're calling, right, is chipping away at the string we're parsing, right?
Yeah.
And say, oh, okay, I need a variant. Cool. Variants begin with an open parenthesis, so I will eat that open parenthesis, right? Line 362 on the right. And then we go to the identifier, right? And the identifier tries to read a string. So it reads the entire string. And then you're left with, depending on the kind of variant, the different thing that will happen. I don't know if that makes some sense. But, you know, like you're essentially directly calling the deserializer from the left.
Yeah. Okay. So let's say for a new type variant in an S-expression,
Yes.
we, I think you have one down here, right? LT,
Yeah.
which would be, yeah. Where's our type for it? So it's a bool option. So we come into deserialized variant, right? That is this guy, right?
Mm-hmm.
That maps to that. And we get the tag.
Mm-hmm.
And we're going to match on less than. And then we're going to call new type variant. And at this point in an S expression, it's going to look something like, let me just write out what this would, I should actually do a copy the serialize because I have an example of this. So right here.
By the way, LT here is a lieutenant.
Oh, I guess that makes sense. So we come down, let's just paste this above, and we'll say this deserializes.
Nice.
Deserializes to,
I guess from.
yeah. Okay. So we've already, we would have already eaten this, right? The tag.
Yeah.
And now, I guess we have to expect white space.
Yeah, you can probably do that.
So we would do like let star equals parse or dot read white space. And that takes our, it takes a reader in. Then we don't need deserialized sequence. We just need to read a value, which I think we can just call d.deserialize or like this.
Mm-hmm. Yeah. Since this serialization, right, the one you chose for new types, is essentially the value itself,
Yeah.
then the only thing you have that can give you that value is the continuation.
Okay. And the continuation for this example is going to be this function here, which is going to, I don't know what, where does D come from?
This is just from the derivation. Like,
Okay.
because it's this derived serializer, I include some things just in case, but we don't need
Gotcha.
to worry about that one.
So then we read an option bool. Yeah, that makes sense. And then our actual variant thing itself is going to eat the right paren.
Exactly. Yeah. Exactly. It unwinds all the way back to the serialized variant, and then you read the right parents, and then we return that value.
Okay, so maybe let's do deserialize. Maybe we should do deserialize even record here, because that would actually, let me just do tuple real quick, because I think this one would be relatively easy. So again, we need to, let me go grab the serialization format. You're right, having like a look at the data as you're doing this makes it a lot easier.
Yeah, like it's otherwise very confusing.
Where's the tuple variant? Right here. No, that's a record variant, first of all. Grab that. Paste that there. Okay. So right now we've read this. We need to eat the white space. So let's just grab this. Come down to here. Paste that in. Find that. This will be reader. And then we need to, I think we could actually, this would be fine, calling sequence.
I think so too. Because you want to have another list, right?
Yeah, so why did that jump me there? Oh, because it's not referencing this one. Yeah, so sequence just says, hey, we're expecting a left paren. We deserialize right paren value.
Yeah, that makes sense to me.
Okay. Well, that one's super easy. And if we do the record, or I assume that's the next one. Let's just grab this. And we'll say deserialize record. Paste that here. Let's see. That goes down to here. What the hell just happened? That is not what I wanted at all.
Classic Vim. At least once a day I have one of those moments. And I don't know if my hands are getting old and they're pressing things I don't mean to, right?
So when we hit a record then, will we have already...
So I think we copy the comment from serialized field instead of the serialized record.
Oh, right.
Because that looks like we're serializing just one field.
That can go here, and then we'll go back up to serialize record. Where's the actual record? Record, right here.
Yeah, that makes sense.
Throw that there. So in this case, we have this thing. Have we already chewed these outer?
No. The record is different from the record variant, though.
Right. Okay. Okay, well then, I guess we can come back to this. Should we do the record variant first?
I think we can do that.
Okay.
Did you see that tweet? I caught Bad Cop recommending OCaml to people.
No, I haven't been on Twitter. I woke up at like 3:30 a.m. randomly, and I had like 20 notifications from Usabit and Tech Savvy Travie. I went through those and then fell back asleep, and I haven't opened Twitter since.
I think one of those might have been this post over here.
Let's see here. You should try OCaml. Bad Cop's so proud of you right now.
Yeah. They tried to come back at me with something, but yeah, we already captured him. Got him.
So good.
Yeah.
I don't know if you were here for this.
I think I missed this.
Freaking Bad Cop got me so good.
I can't hear anything, by the way.
Oh, all right. I'll just send this clip.
You can just send me a link. I'll watch it over here.
But I'll play for. I'm gonna dump it in chat. But I'll play for chat too.
Dude, this is brilliant. I saw it with like a second delay. I had to watch it on my own screen, right? But my God. Got him.
I did that last night, and I must have just never cleared the terminal from curling that endpoint, and
Yeah.
flashbanged myself in chat right after a DevDad raid this morning.
Damn. Hilarious.
All right, so here we've already eaten the constructor, and we gotta do the same thing. We want white space, and we go ahead and put that there, and then we don't deserialize, or maybe we do deserialize a record. Is that what we would want to call?
Sorry, can you repeat that? I spaced out for a second.
No, you're all good. So we're looking at deserializing a record variant, and when we get to here, we've eaten to this point.
Yeah, exactly.
And then we eat the white space, and then in yours you call deserialize record.
Exactly.
Which would be size. Where does this what does this empty string do here?
Essentially, we're passing a record type name that is empty because we don't really have a record type name. It's an anonymous record. This API could improve, but typically records have a type name, right?
Yeah.
Like the only case where they don't is where they are essentially a record inside of a inline in a variant.
Gotcha. So what if I ended up doing something like if I made this type point equals that, does that change anything?
Yeah. So now you have a new type variant.
Oh, right.
I think that will serialize to the same thing, actually. Well, I guess this is a new type variant. And new type variants are like the name of the constructor and then the value. And because of how you're serializing records, that's kind of nice of your format here, right? That you can refactor some of the code, right? And still have the same serialization. Because the record will serialize to the same thing, like a list of top of pairs, right?
Yeah. Okay, that makes sense. So we eat the white space. We are now here, and then I suppose we would need to implement deserialize record next.
Exactly. Yeah.
Okay, so we drop down to here. Let's uncomment this. And when we deserialize a record, I assume there's one up here somewhere that we can look at. So like a record.
We have a record test. Yeah, you're right. Like if you look at the line 77, right? So essentially, that function, that continuation, is what will get passed into the serialized record, right? Because we call record variant first, and that right now just doesn't do anything. It just calls the serialized record, right?
Yep.
So then that continuation is what will get called in the middle in line 408 on the right.
Okay. So here, peak reader. I assume we don't need this white space skip.
I think it doesn't hurt.
I don't even have skip white space.
But you have like a read white space, right?
Or skip space. I should rename that to skip white space, but
Yeah, but immediately afterwards, like if you have a record here, I don't think you want to peek. I think you just want to do the thing.
so if we have a record, why wouldn't we want to peek? I guess
Yeah, like you don't have many options here. It's like either you read an open parens or you fail.
Okay, I see. So
Which is also a comment on the JSON one because like it probably needs to be improved.
Although I don't really think we need this skip space, do we? I mean, obviously it doesn't hurt, but let me make sure that doesn't do anything funky. With star white space, so 0 more. Okay.
Oh no, wait! I think we cannot call that.
It should be good because of the
if
star,
you have
right?
Right. Okay. So then this will always succeed.
Yeah, I don't think we ever hit this assert fail.
Okay, that's cool then. I was like, oh no, if we find anything else, it will assert fail. That sounds bad. That sounds like, yeah.
So skipping space isn't going to hurt anything. And then we need to effectively say we want to eat a left paren.
Mm-hmm.
And then another left paren.
Well, not quite, right? Because you don't really know how many fields you have. You don't know how to parse the fields, but you have a continuation fields that knows how to do that.
Right.
Because at this point, maybe you know the number of fields you have, like 5 fields in your record, but you don't know anything else about them, right?
Yeah.
And you want to be, yeah. So the function on the left is the thing that really drives the module on the right.
So then we do this. And yoink that. And then OK value.
Yeah, that looks about right. I think it's both a little confusing, but also crazy powerful how these continuations work, because the parser doesn't do much. You know what I mean? It's like, oh, I'll just read a parenthesis and just call the thing, and that's it,
Yeah,
right?
yeah.
And at the end of the day, they sort of join together and they do this Megazord parser thingy that is getting the value you want.
So when we go into deserialize record, that's this function, right? That's this continuation.
Correct. In that continuation is called fields on the right.
Yeah. Wait. When does deserialize? Isn't deserialize record this whole continuation?
No. So in line 77, we call record variant, right? And that calls deserialize record variant. And deserialize in line 381. And deserialize record variant, with on line 381. that
the
calls
white
the
space.
serialized record.
Ah, right. Okay.
It doesn't have to. You could have a different encoding, right, for record variants in some other way. But
Right.
I guess it's kind of convenient to have the same representation.
Okay, that makes sense. This is like mind bending.
It is, yeah.
So if we then deserialize a field, we say field, that would be these continuations, right?
Correct. Every column field on the left corresponds to the serialized field on the right.
Okay. So we need to check if we're first. And if we are, deserializes. Oh, I screwed this up. This should actually be.
I think that makes sense. But one of the sort of inputs that is valid is also an input that begins with a space.
It begins with a space.
Like space, open parentheses, X, space 6, close parentheses, right? Because like if you have multiple fields, then the first one doesn't need the first space, right? But every other field needs that space before it.
Right.
And I think we also have written something like this already in your parser, right? For sequences.
I actually, yeah, we might actually be able to use read sequence. Or maybe we wouldn't be able to. So if we look at deserialized sequence, it looks for a left paren and then a right paren.
Sorry, deserialized element. That one does the inline 340. That's the part that we want there.
Okay. I think that's what I just wrote anyways, but I'll grab it just in
Cool,
case.
no worries.
I think that's what we effectively did. S.kind rest, we get the value. Yeah, that looks similar.
Yeah.
Let me just do that. So if it's the first one, we're gonna return okay, which would give us X, right?
Well, if you look at line 420, we're just immediately pattern matching on that okay, right? So we don't do anything. We just go to line 423.
Right, then we set to the rest. We read the field name, which we read a string, which would be the X. And then as long as the field name equals what we'd expect, which comes from here, we would read in this case, a white space. And then we grab the value by calling deserialize self.
Yeah, like the continuation again. So that will mean at that point on the left, if we manage to parse a string, right? After reading the name and so on, then we'll just return that okay string, and then we can pattern match that on the left, and you get the variable name.
This is wild.
I know, right? It is. It has been very frustrating trying to make it work as well. Because in Rust, all of this is done via traits, right?
Yeah.
It's not easier in Rust either, right? But it's like you have to keep it in your mind. Okay, I have this new value of a new type. I need to find the trait implementation, right? And try to see how the functions get hooked up together. In some way, I think this is even easier, but it's also very confusing because the code doesn't really tell you where it goes, right? It's like I'll do a
Right.
little bit here, and that's it.
Yeah, it's hard to know just looking at this where the continuation comes from.
Yeah, it is.
Well, this will be sweet when it's I mean, the JSON one's pretty much done, isn't it?
I think so. I think we're only missing the ability to read JSON in out of order, right? The fields out of order.
Did we end up
Okay,
adding floats? Did you get that in?
no, we have an issue for that to add floats, and I'm trying to think what else are we missing. Maybe chars. I don't know if JSON has chars.
I don't think so. If you go look at you have to have your JSON in here somewhere, right? If we go to, let's go to safe. Are you really not gonna?
Yeah. He's just like, nope.
Is there not a MLI in here for your JSON safe? Here we go. So these are the things we'd probably have to, yeah, int.
So it looks like we're missing float.
Yeah, that seems like it. Because like I don't think you can't deserialize big ints, you can't deserialize dates or anything like that.
Right.
Or I mean serialize. Sorry. Can you not serialize undefined?
I don't know. Is undefined part of JSON? I know null is, but
Let's find out. I thought it would, maybe it's not.
I have like 30 collective years of experience, and we can't tell the basic questions, right?
JSON. Sorry, this is so tiny.
I think it's gonna be null.
You think so?
Yeah.
I think you're probably right. Empty. Just
What?
drops the key value altogether.
Okay. So maybe not.
Rip.
Rip. Yeah. But
I mean,
today
you
we
could
learned.
always, like, if you really did want to do it, you could add like a replacer in as the, what is it, the second or the third argument to stringify. But that wouldn't be within the spec or the normal spec. Don't use JS as an example for anything.
I think at the very least for JSON, JS is the authority.
Cool. Well, I'm gonna have to wrap up streaming here a little bit early this morning. I think we should be able to like start working on test. I will probably actually work on tests off stream today.
As soon as you have like most of the serialize and deserialize pair functions together, you should be able to use that test suite, the JSON, the JSON test suite, right? Because
yeah.
that test suite has nothing to do with JSON. It doesn't assert on any JSON at all, right? It is grabbing some values, OCaml values, and does the round trip, right?
Well, in that case, we should be able to actually write that, because the only thing I have left to implement is of string or toString. I forget which one here. Of string. Everything else is implemented one for one with you now.
Cool. That's awesome.
So if we do this, we get a deserializer, we get a string, and we say let state. This will be our string guy first. That looks super similar. Do I not have a create in here? From string. I should have, or wait, that would be in this struct here.
Is Sabine still reading?
I don't know. Let me pull up Twitch.
Yeah, she's.
Cool. We'll read Sabine then. Do I not have enough string in here? Doesn't look like it. Okay, well, we can just do, get rid of that, and we'll say, oh no, we do have a string.
I think there's one there.
Should, unbound module, oh, so I have to do this expression. What? That seems like it should be right.
Yep.
Is it because... Right now I'm confused. Oh, my... Is it because I opened like a local scope or something?
Could be. I'm not sure.
What does this return?
Oh, string is okay.
Oh,
Right.
I see what's happening. I have a T here, and this would have to be this would be lexbuff. I guess that would be an equal, not a.
Yeah, and you will have to take a parameter and call it.
There we go.
There you go. That makes sense.
That makes a lot more sense.
What are we missing?
I am not sure, admittedly.
Can you check the doing output? Deserialize int. Any chance you have deserialize uint?
Maybe.
Because I remember you folks were talking about that. No, it's right there. What's the signature? Oh, I think deserialize int 8 should return a char. Because a char is essentially
I thought I had fixed this.
8 bytes.
Did we not fix this? I guess we would just do char event here then. Yeah, okay. Well.
Nice. So the easiest way to test this, if you want to grab the serde.json module, right? We just need to replace the module serde.json with the module serde.expert in that module, and we should be able to run all the tests.
I think that's what this is, right?
But you're missing all of the tests that we already have there.
Oh, okay.
Because all of those tests have nothing to do with JSON, right? They're just like, hey, here's a variant, here's a record, and whatnot, right? And the serializer and the deserializer, they should essentially be the same for both. So the only thing that changes there is the format.
Oh yeah, this was the thing I ended up writing the other day. And okay, so we'll say %s/serde JSON with serde S-Expression.
Yeah, I believe that.
Right, I broke that because we don't have the Lexer file anymore. Right, there's that temp file that we don't need anymore. Okay, we're built. You feeling lucky?
Feeling lucky. Go for it.
Okay, well, we're broken, but that's okay.
But this is JQ. It could be worse.
Am I missing JQ? Is this Jesus?
For the PPX tests. I thought we fixed that.
I left my shell.
Oh, okay.
I should just add that to my home
Nix.
manager setup.
No worries. One last thing, we can go into the serde expert test. And I think there's some other mentions of the word JSON. We can just replace JSON for Sexper, and that would be good.
Sweet. Come on, Nix.
Yeah.
I literally
That's taking
installed this
a
yesterday.
bit. Yeah, it should be cached locally, right?
I don't even think I ran garbage collection yesterday. I know I didn't. Oh my god, Dylan without glasses. My eyesight's actually not that bad, chat. I just wear my glasses because I have a bit of an astigmatism and like not perfect, so it's just easier. And I have what's it called, blue light lenses in these.
Right. What kind of correction do you have?
I
Myopia
forget
or
what my exact
astigmatism?
prescription is, but it's like it's laughable. It's like not bad at all.
Okay.
I mean, it's been getting worse every year. Like even
Yeah.
now with these, like I had 20/20 vision until I was 22, and then every year since it's got worse and worse, and my prescriptions got stronger and stronger.
Right.
But like Justine, she's blind as a bat. Assertion failed
What?
in
You have an
Dune.
assertion. It's not in the test. It's in the serde expert module.
Oh,
9392.
392. Okay, well, classic.
Yeah. I think we were talking about whether peak was gonna be the problem or not, right? Like, are we reading
Yeah,
the current or the next? Can you remove that match? Just leave the body, the good part.
yeah.
I have a feeling that that match there is it's not gonna help. Okay, there we go. That's our first test. And if we make this pass, then we should be good. We don't need to do this right now, but
Yeah.
you
I'll
should. Yeah,
I'll be working on this on and off today in my free time. So
no worries. Looking forward to using this library. I
yeah,
feel
me
like
too.
this
This is gonna
weekend
be sweet.
I might do a TOML unless somebody wants to help and do a TOML parser because I really want to start configuring things via files.
Oh, that would be sweet. Tom will be great. Then we just need a translator from S-Expressions to Toml, and then
Actually, now that you say that, one of the great things about this serde model, right, is that we can read from one file into your
yep,
data
yep.
and we can print straight to TOML. So it will be zoom done.
That's what I'm saying. We
Yeah.
could like put
See, man, you get it.
we could put something in front of Dune, and write our
Yeah,
frickin' Dune files in
exactly.
Toml,
Yeah,
and
it
just
will be
parse
like
it with a real
doing the
light
TOML.
layer to Toml. Like
100%.
right? Yeah, I want it. I
I would
want it
love
so
that.
bad.
Yeah, that would be a lot of fun as well. Damn, are we doing this? Are we really doing this? Doing fork? Doing fork?
Did you?
No,
Well,
no,
last
not a
night
fork.
you probably were sleeping, but Tej was working on looking into what it would look like to update OCaml LSP and Dune to get code actions and some better autocompletes uh, in Dune files too.
Nice. Is it like to
So,
complete from your targets or like complete via like the
I mean,
available stanzas?
probably do all that, but like
Nice.
he was mostly looking for like if you're in your Dune file, right, and you were like
Mm,
here, you could press like this and just get like a list of like what are my available things, and then like docs with it,
nice. Yeah, that makes perfect sense.
or like being able to press like Shift K here and get hover docs for these various atoms.
Right, like what's the signature of test? What are the things you can put there?
Yeah,
Love that. Love that. We
yeah.
need that.
It's a pain in the ass though. What he found.
You found it's a pain. Oh no, that's bad.
But yeah, hopefully he follows through on it because I think that would be really good to have.
I think so too. I think it would be a big plus for everybody that's jumping into Dune.
Same. It would make learning so much easier. All right, I am gonna raid Sabine, and I'll be hanging out in chat. So I'll be around. Thank you for your help as always.
Anytime, Dylan. See you, folks. See you, chat. See you in Sabine's chat.
And we're going to raid Sabine. Start raid.
I'm guessing I'm gonna be taken to the raid as well if I stay here.
You should be, but yeah, I think we can hang up here. So yeah, man. Thank you. I will chat with you later.
Yeah.
Peace.
See you.